So, in the process of visiting customers that are having issues with interface and surface related um, manufacturing steps, we've come across a lot of examples that have helped us recognize the importance, first of all, recognize the existence of critical control points and, and appreciate the importance of this recognition in ensuring product quality. There's a great example from the aerospace manufacturing um, segment where aircraft, there's a lot of adhesive bonding going on in aircraft construction, and a lot of these processes are still manual. So for example, there could be a step where a surface is manually cleaned with a solvent and a wiper prior to bonding a component onto an airplane. And we had one customer that was experiencing all of a sudden lots and lots of failures in this bonding process. However, they were performing, to their eyes, they were performing this process the exact same way they've always performed it. The same people were performing the process. They're using the same solvent. They're using the same type of wiper to perform this process. And we came in to take a look at this process with them and try to identify where the problems might be occurring. And we went in and we did some contact angle measurements prior to and just after prepping of these surfaces, cleaning these surfaces with the solvent-soaked wipers. And we noticed right away that after the solvent wipe, the contact angles actually went up quite a bit, which indicates that the solvent wipe process wasn't actually cleaning the surface, but it was contaminating the surface in some way. So we investigated a little bit farther, and we found that the purchasing department had identified a vendor for wipers that was significantly cheaper than the vendor they had been using. And these wipers were actually recycled cotton cloths, and they looked clean. They smelled clean, and that's a clue. They smelled clean. And the operators were taking the wipers out of a box, applying solvent, wiping the surface, and getting adhesion failures. So we actually went into the bathroom and got a paper towel out of a dispenser and went onto the manufacturing floor, and using the same solvent, tried wiping the surface, and the contact angle dropped significantly, just the way one would expect from a solvent cleaning process. So this pointed out the wipers as being an issue, and we took the wipers back to our laboratory and we wiped some clean metal surfaces and looked at that spectroscopically, and we identified that the wipers were actually not well rinsed, and they were transferring detergent onto the surface as part of the wiping process, and hence that clean smell, right, that we noticed with the wipers. So here's an example of a process where process control consisted of a defined set of process steps that were repeated time after time. And the hope is that if we do this the same way each time, if we hold the rag the same way each time and hold our mouth the same way when we're doing the wiping process, we're going to get the same outcome, right? But that's, of course, that's a fallacy. And what one needs to do is actually measure the properties of, in this case, the surface that we expect to bond to make sure that our defined process steps are creating the same surface every time, right? It's an example of seemingly minor changes in a process having a very large effect on the outcome of that process. And this is one of those experiences that clued us into the existence of and the importance of critical control points in a manufacturing process, right? So in this particular process, a critical control point is the surface immediately after wiping with the solvent-soaked wiper, right? Have we got the properties to that surface that we expect? Or do we have a dozen molecular layers of a contaminant on that surface transferred by the wiper?